Hi guys, welcome back to Data Every Day. Today it's going to be a short one because it's late and I just want to get this done. But it's basically a data set about food preferences, and we're going to try to predict the age. Well, we'll do an age group based on a bunch of these other attributes. So let's get started. I've already imported the normal libraries, and today we're just going to use a min-max scalar, train test split function, and logistic regression model for a simple classification. We'll load in our data using the pd.readcsv function, and we can get the file path from right over here, paste it in, run that, look at the data. We can see we have a few useless columns here, just timestamp and participant ID. So let's go ahead and drop those. Very easy, timestamp and participant ID, and axis 1 for columns, and in place is true. Alright, take one more look at our data. Now we have better, easier to work with dataset. And basically, let's just get some preliminary information about the data. So we can see we have only one integer column, that's the age, that's what we're going to try to predict. And we have, as you can see, gender and nationality and food and juice and dessert are all objects or strings. So what we're going to do is first we can see this actually has 4 missing values. There's 288 total values, total rows, and 4 of these values are missing. So because it's only 4 rows total, right, we're just going to drop those from our data set. So here I'll just write missing values, and we're just going to do data.dropNA, which will drop any rows or columns depending on the axis we specify that have null values. And we are specifying the row axis here, and in place true. And after that, we're just going to reset the index, and drop equals true means we're going to drop the old indices, and in place true. Alright, let's take a look at our age column now, because this is the one we're going to be working with, and it's going to be hard to predict the it's going to be hard to predict how exact age based on this small set of features. So we're going to bin it, which we're going to put them into young and old. And for that, we're going to use the pandas.qcut function, which is a quantile cut of the data, and we're going to cut the age column into 2 bins, and we'll label them 0 and 1. So we want to look at what that looks like. Labels, not label. Now it's going to be 0 and 1 depending on if it's young or old. And I'll just assign this to age bins. And it's not really young or old, it's just based on how the data is spread. So the older and younger would be better. So we're gonna I'm just gonna show you if we put the age column right next to these new age bins that we have. It will look like, oh, I didn't run this. Okay. You can see anything below a certain value is going to be 0, and anything above a certain value is 1. And it looks like all these, anyone in their 20s is going to be 0, and 31, we can't really see the cutoff, is 1, but that's probably because the distribution is more weighted towards younger people. The mean of the distribution is probably around late 20s. We could actually check data sub age dot mean, and it's 30.6. So you can see anything below 30 is going to go to 0, anything above 30 will go to 1. Okay, so now we'll do encoding. Oh, I have to actually set this. Let's set data sub age to be the age bins. Okay. So now encoding, and basically we're going to list out the categorical features we have. And these are all the ones except age. So we'll just take a look at our data. we have gender, nationality, food, juice, and dessert. So it just so happens that everything is categorical. And then let's just define a function. We'll call it getUniques. This is just going to show us what kind of values are in each of these categorical columns. So we have some data frame and some list of columns, and basically we're going to return a dictionary that's going to be a list of it's going to be a dictionary that maps columns to the unique values in that column turned into a list. And that's for each column in columns that we specified. So now if we just do getUniques for data and categorical features, you can see gender has male and female, nationality has all these, food has traditional food and Western food, juice has fresh juice and carbonated drinks, and dessert has maybe, yes, or no. So what we can do is separate these into binary features, ordinal features, and nominal features. So binary will be anything that takes on two values, so male and female is binary, so gender will go in here. Nationality is nominal because it has no order. Food is also binary. Juice also binary. And dessert is going to be ordinal because you could say no comes before maybe, which comes before yes. So dessert. Alright, and we're going to need three different functions, one for each of these. So for binary features, we'll have a binary encode function that will take in some data frame. It will take in a column that we wish to encode and the positive label for that column. And we're just going to create a copy of the data frame so that we're not modifying in place. And then we're going to say that column, we're going to apply a lambda function to the column that we want to encode. And this lambda function will take in some x and return 1 if x is the positive label that we specified. And otherwise we'll return 0. So this would be 1 and 0 depending on whether or not x is positive label. And then we can just return df. Okay, then we have an ordinal encode function, which will take in some data frame. It will take in the column we want to encode, and it will take in some ordering of that column which we specify. And df is we're just going to make a copy again, df.copy. And then we're going to apply another lambda function here. So .apply, lambda takes in some x, and it's going to return the ordering, the index of that x in the ordering we specify. So you'll see when we do the ordering, I'll explain what that does. And return df. Alright, and last, just a one-hot encode, which is going to take some data frame, some column, and that's it. What we can do is create another copy for this one, and then we're going to make a dummies data frame, which will just be pd.getDummies for the column of our specification. And that's just going to make a column of 1s and 0s for each unique value in the column that we specified. And then we're just going to add or concatenate the data frame and the dummies next to each other. And then we'll drop the original column from which we created the dummies. Alright, then we return the data frame. And then we're just going to encode them all. So these are the ones we use in binary encode on, these are the ones, this only one we do ordinal encoding on, and this one we do nominal encoding, or one-hot encoding. So for the binary features, we'll say, because it returns the data frame as a whole, data equals binary encode, data, gender, and then we have to specify a positive label, which is male as per convention. Then the food column, our positive label there, will be, we'll say, traditional food. Alright, and then our, we're gonna do the juice column, and we'll make the positive label fresh juice. Alright, and that's actually should be capital. Okay. Alright, and then we have to create a ordering for the ordinal column, so we'll call it dataset ordering. And this is going to be an ordering of the preferences, so no, maybe, yes in that order. No will be the least, maybe will be the second in the middle, and yes will be the most. Then we'll just say data equals ordinal encode data dessert, and dessert ordering is the ordering that we're passing in. And then for the nominal features, we're going to encode using one hot encoding. Data equals one hot, and there's actually only one hot encode. Data, comma, what's the nationality? Alright, and we run that. Take a look at data now. The whole thing should be numerical form. And so now we're ready to split and scale our data. So let's do that. Scaling and splitting. And we can split it into y and x. So y is just going to be data sub age. Will just be our classification column right here. And x is going to be everything except age. We need to drop it from the column axis. And then our scalar is going to be the min-max scalar that we imported from sklearn. And x is going to be scaled by the scalar. Alright, now we'll split it into train and test set using xtrain, xtest, ytrain, ytest equals train test split xy, and we'll give it a train size of 70%. Alright, now we can training, and we're just going to create a simple logistic model here, logistic regression, which we imported from sklearn. Model.fit xtrain ytrain, model.score xtest ytest. And we have accuracy of about 70%. So that's pretty good, especially considering the limited data we have, and that it's sort of predicting their age based on their food preferences. It's very interesting that there's actually something of a pattern there that we're able to pick up on. So I think that wraps it up for today. Thank you so much for watching. If you enjoyed, make sure to subscribe and hit the bell, and leave a comment in the section below. So I'll see you guys tomorrow. Thanks so much for watching. I know it was a late video, but I'll have one tomorrow morning. I'll see you guys tomorrow.